Hello, my dear student. Today I am going to discuss about EDEXCEL IGCSE O-Level Physics. Today I am going to start a new series, Past Question Paper Solution. I start a new session, Year-wise Question Paper. Hello, my dear student. Today I am going to discuss Pearson EDEXCEL International GCSE 9-1 brand new question paper Jan 2021. Chapter Physics, Unit 4 PH1, Science Double Award 4 PH1, Paper 1. Instruction: use black ink or ballpoint pen. Fill in the boxes at the top of the page with your name, center number and candidate number. Answer all questions. Answer the question in the spaces provided. There may be more space than you need. Show all steps in any calculation and state the units. Some question must be answered with cross in box. Cross. If you change your mind about an answer, put a line through the box and then mark your new answer with cross. Information: total mark for this paper is 110. The marks for each question are shown in the brackets. Use this as a guide as to how much time to spend on each question. Advice: read each question carefully before you start to answer it. Write your answer neatly and in good English. Try to answer every question. Check your answer if you have time at the end. There is a formula sheet here. You may find the following formula useful. Question number 1. Answer all the questions. The passage describes the evolution of a star with mass that is much larger than mass of the sun. Use words or phrase from the box to complete the passage. Each word or phrase may be used once, or more than once, or not at all. Total marks in this section 6. Word selection: chemical, contract, expand, gravitational, kinetic, main sequence, neutron star, nuclear, protostar, supernova, vibrate, white dwarf. Hydrogen atom in a nebula move towards each other due to the force of gravity. Hydrogen atoms in a nebula move towards each other due to the force of gravity. As the atoms move towards each other, their kinetic energy store increases, which increases the temperature. If the temperature becomes high, nuclear fusion of hydrogen will start and star enters the main sequence stage. Main sequence stage of its evolution. When hydrogen fusion stops it in the core of the star, the core of the star will start to contract. This increases the temperature in a layer surrounding the core. Hydrogen fusion restarts in a layer surrounded the core. This causes the star to expand, and its surface temperature decreases. The star is now red supergiant. Eventually, nuclear fusion stops in the core of the star, and the star explodes as a supernova. Supernova. The core of the star collapses to form either a neutron star, or a black hole. So, hydrogen atoms in a nebula move towards each other due to the force of gravity. As the atoms move towards each other, their kinetic energy store increases, which increases the temperature. If the temperature becomes high enough, nuclear fusion of hydrogen will start, and the star enters main sequence stage of its evolution. When hydrogen fusion starts in the core of the star, the core of the star will start to contract. This increases the temperature in layers surrounding the core. Hydrogen fusion restarts in a layer surrounding the core. This causes the star to expand, and its surface temperature decreases. The star is now red supergiant. Eventually, nuclear fusion stops in the core of the star, and star explodes as a supernova. The core of the star collapses to form either a neutron star or a black hole. Question number 2. A speed camera positioned at the side of a road. The camera measures the speed of a vehicle on the road to determine whether the vehicle is traveling too fast. The camera takes two photographs of the vehicle 0.25 second. The photographs are used to measure the distance traveled by the vehicle during this time. State the formula linking the average speed, distance moved, and time taken. We know average speed equal to distance moved divided by time taken. So average speed equal to distance moved divided by time taken. Now we have to find out the average speed. In question number 2, in the time between two photographs, the car travels a distance 6.5 meters. Calculate the average speed. Calculate the average speed of the car. We know average speed equal to distance moved divided by time taken. Here distance moved 6.5 meter and time taken 0.25 second. So average speed is 26 meter per second. So answer 26 meter per second. Now question number 3. The speed limit of the road is 80 km per hour. Determine whether the car is exceeding the speed limit. So 80 km per hour. 80 km divided 1 hour. So 80 km into 1000, because 1 kilometer equal to 1000 meter, and 1 hour equal to 60 minutes, then 1 minute equals to 60 seconds. So 80,000 meter divided 3600 second. So 22.2 meter per second. So the car is exceeding the speed limit. Speed limit. So 80 km per hour, 80 km per hour means 22.2 meter per second. So our here speed of the car is 26 meter per second, which is more than the speed limit. So the car is exceeding the speed limit. Now next question. Question B. The velocity time graph shows how the velocity of a lorry changes with time. It is a velocity time graph. Velocity in meter per second. Velocity is in meter per second and time in second. Explain how the graph shows that the lorry has a constant acceleration. We know acceleration is the gradient of the graph of the velocity time graph. Here graph has a constant gradient or the line on the graph is straight. So explain how the graph shows that the lorry has a constant acceleration. We know acceleration is the gradient of the velocity time graph. Here graph has a constant gradient. The line on the graph is a straight. Now state the formula linking acceleration, change in velocity and time taken. We know acceleration equal to change in velocity divided by time taken. Calculate the acceleration of the lorry. We know acceleration A equal to V minus U divided by T. Here V is the final velocity, U is the initial velocity, and T is the time. Here initial velocity of the lorry, look at the graph. Initial velocity of the lorry is 5 and final velocity 24. 5. Initial velocity is 5 meter per second and final velocity is 24 meter per second. Here time 60 seconds. So 24 minus 5 divided by 60. So 0.32 meter per second square. Remember, the unit of acceleration is meter per second square. Now new question number C. Question number 3, the photograph shows a mains operated decorative lamp X. It is a decorative lamp X. Lamp X has 7 identical bulbs. That are connected in series. Give disadvantage of connecting the bulb in series. Main disadvantage of connecting the bulb in series is if one bulb fails, all bulbs turn off. Turn off. If one bulb fails, all bulbs turn off. It is the main disadvantage of connecting the bulb in series. Another disadvantage, bulbs cannot be controlled individually. Suggest an advantage of connecting the bulb in series. The main advantage of connecting the bulb in series, all bulb controlled with one switch. Another, you can write, the circuit is simpler. Now question number C. C1. Each bulb has working resistance 390 ohm. The voltage across the bulb is 33 volt. State the formula linking voltage, current and resistance. Voltage equal to current into resistance. We know voltage equal to current into resistance. Symbolically, V equal to I into R. Calculate the current in each bulb. We know V equal to I into R. So I equal to V divided by R. Here voltage 33 volt and resistance 390 ohm. So current 0.085 ampere. Unit of current is ampere. So answer 0.085 ampere. is greater in lamp Y. Why? Because more energy transfer to each bulb in lamp Y. Resistance of circuit in lamp Y is less. Current in bulb or circuit in lamp Y is greater. Question number 4. The photograph shows a hair dryer. Plugged into main supply. The hair dryer contains a fuse. State which wire in the hair dryer should be in series with fuse. Remember, fuse must be connected in live wire. So answer is live wire or L wire. Or red or brown insulated wire. Because live wire is in brown or red insulation. So question A, live wire or L wire. Question B, the fuse is an electrical safety feature used in mains operated domestic appliances. State two other electrical safety features that can be used in mains operated domestic appliances. contains a coil of wire which is used to heat air passing through the hair dryer. Explain why the coil of wire heats up when there is a current in it. Handling source the time handling the source or use of lead apron or shielding. Radium 226 can be presented using the symbol. How many neutrons are in the nucleus of an atom of radium 226? We know this one is the atomic number. Atomic number is equal to the number of protons present inside the nucleus. And this is the mass number. Mass number is proton plus neutron. That means atomic number plus neutron number. So how many neutrons are in the nucleus of an atom of radium 226? So neutron equals to mass number minus atomic number. So 226 minus 88. So answer will be 138. 138. So Newton number equal to mass number minus atomic number. Question number C. The teacher investigates the type of radiation emitted from the radioactive source. Give the name of piece of apparatus that detect ionizing radiation. Ionizing radiation can be detected by using Geiger-Müller counter. Geiger-Müller counter or only GM tube. GM tube is the short form, or photographic film. Photographic film. The teacher finds that the radiation emitted from the radioactive source is not detected when the detector is more than 5 cm away from the source. State the type of radiation emitted by the radioactive source. It is a alpha source. Alpha source. Because alpha particle has short range. Alpha particle can be stopped by few centimeter ER column. Now, question number D. The number of radium 226 atoms in the source decreases over time with half-life 1600 years. State what is the meant by the term half-life. Half-life. What is half-life of a radioactive source? The average time taken for a radioactive substance. The average time taken for a radioactive substance for radioactivity to half. or the average time taken for a radioactive substance for radioactivity to halve. Or you can write the average time taken for a radioactive substance for half of the radioactive atoms to decay. So half-life is the average time taken for a radioactive substance for the radioactive to halve, or for half of the radioactive atoms to decay. The radioactive source contains 2.66 10 to the power 21 atoms of radium 226. Approximately how many atoms of radium 226 will remain in the source after 800 years? It is approximately 1.88 10 to the power 21 atoms. So, my dear student, part 2. Today I am going to solve International GCSE 9-1 O-Level Physics question Jan 2021, paper 1, part 2. When a rubber ball is dropped, it hits the floor and bounces. Design an investigation to determine how the temperature of the rubber ball affects. How the temperature of the rubber ball affects the maximum height of the ball reaches after it bounces. The maximum height the ball reaches after it bounces. In your answer, how to change the temperature of the ball? Variable that need to be controlled. Variable that need to be controlled. How to obtain high quality data. How to obtain high quality data. Okay, we can student can use water bath, water bath, or heating water in beaker. The beaker. There is a thermometer. Thermometer used to measure the temperature. Here thermometer is used to measure the water bath is used. So how to change the temperature of the ball? Here, water bath is used to change the temperature of the ball. Here thermometer is used. Thermometer is used to measure the temperature. The temperature. Or temperature sensor. Temperature sensor can be used. Here control variable is ball dropped from rest each time. The height the ball is dropped from must be same. We can increase accuracy of measuring bounce height, measuring the bounce height, bounce height by using recording with slow motion video camera. At least 5 different temperature tested. Repeats and average for each case. So question number 7. Very strong magnet can be made using the element neodymium. Neodymium. Diagram 1 shows the part of the two neodymium magnet X and Y when they are held to close together. Question number 7. Very strong magnets can be made using the element neodymium. Diagram 1 shows the part of the neodymium magnets X and Y when they are held close together. Magnet X and magnet Y. A uniform magnetic field is produced in the space between the magnets. Diagram 1 shows the north pole of the magnet. Complete the diagram 1 by drawing the uniform magnetic field leveling the pole on the magnet Y. So, north pole. Uniform magnetic field equally spaced here, and magnetic line of flux start from north pole and ended at the south. So remember, lines drawn straight and vertical between the magnets. So north pole labeled on magnet Y. Lines drawn straight and vertical between magnets. Lines are equally spaced with arrow pointing upward, because it is a uniform magnetic field. So lines are equally spaced with arrows pointing upward. Upward. Diagram 2 shows another neodymium magnet being used to lift an iron ball from a table. The iron ball is shown at the instant it leaves the surface of the table. Magnetic force, and table. Explain why the iron ball experiences an upward magnetic force. Because iron is a magnetic material. Iron is A magnetic material. Material. Iron ball is attracted to the magnet. Is attracted to the magnet. To the magnet. The iron ball experiences an upward resultant force at the instant shown in the diagram 2. Draw a level arrow on the diagram 2 to show the weight of the iron ball. Weight of the iron ball iron ball stays same. Stays weight of the iron ball stays the same. Magnetic force increases as the iron ball moves towards the magnet. Question number 8. A student uses a computer simulation to investigate the motion of a particle in a gas. He records the pressure of the gas and the mean speed of the particle in the gas at the different temperature. The graph shows his result. Pressure in kilopascal and temperature in degree Celsius. The mean speed of the particle in meter per second and temperature in degree Celsius. Question A. Give a reason why the student does not start the y-axis scale from 0 on either of his graph. Because the pressure of gas or speed of the particle cannot be 0, cannot be 0. Describe the relationship shown by the graph. Look at the graph. As the temperature increases, pressure or speed of the particle increases. Relationship is linear for pressure but relationship is non-linear for graph 2, that means for speed of the particle. One, relationship is linear. Relationship is linear. relationship is linear. But for graph 2, relationship is non-linear. Relationship is non-linear because decreasing gradient of the curve. Because in graph 2, decreasing gradient of curve. Explain why the value of the temperature choose in the situation should not decrease below minus 273 degrees Celsius. Because this temperature minus 273 degrees Celsius is absolute zero temperature. Absolute zero temperature. Zero temperature. Pressure or speed of particle of gas would be zero at this temperature. At this temperature. The student then calculate the kinetic energy of a single gas particle at each temperature. Using the curve of the base speed on the graph 2, determine the mean speed of the gas particle when the gas temperature is 100 degrees Celsius. 100 degrees Celsius. About 520 meter per second. 520 meter per second. About 520 meter per second. About 520 meter per second. The mass of the single gas particle is 5.3 10 to the power minus 26 kg. Calculate the average kinetic energy of the gas particle when the temperature of the gas is 100 degrees Celsius. We know kinetic energy equal to mass half into mass into speed square. That means kinetic energy equal to half mv square. So half mass 5.3 10 to the power minus 26 kg and speed 520 meter square. So calculate this one. About 7.2 10 to the power minus 21 joule. So answer will be 7.2 10 to the power minus 21 joule. Calculate the temperature of the gas in Kelvin when its temperature is 100 degrees Celsius. So 100 degrees Celsius. So we have to convert it into Kelvin. So in Kelvin equal to theta degree Celsius plus 273. This is the formula. So 100 plus 273. So 373 Kelvin is the way to convert degree Celsius to Kelvin. On the axis, sketch a graph of the average kinetic energy of the gas particle against temperature in Kelvin. Like this one. Because at 0 Kelvin, the average kinetic energy will be 0. That's why, and so answer will be straight line with positive gradient. With positive gradient. Line passes through the origin, and line passes through the origin. Through the origin.